In this video, I want to have a look at functions. So you've been looking at functions for years in your maths classes, but now we need to start getting a little bit more formal with our definitions and our notation. So our definition is, if one quantity, for example y, is determined by another quantity like x, as a result of a given rule, we say that y is a function of x, and we write it as y equals f of x. So that rule, the given rule, is almost always an equation, and sometimes there's some restrictions on it as well. So for example, we might say the function y equals x outside of x minus 3, where x is greater than minus 3 but less than 3. So this sort of thing, this equation here is something that you're pretty familiar with. You've looked at this sort of thing for years. It's just this formal definition of what a function is. And this is an example of the sort of restriction that might be put on our function. So another definition of a function is that it's a relationship between two quantities, for example x and y, where every x value has only one y value, so that y value is unique. On the other hand, there's this other thing called a relation, and a relation is really similar to a function, but our x values are allowed to match up with more than one y value. So for example, if we had the equation y equals x plus 3, we can have a look and see whether this is going to be a function or a relation. So if we plug in a couple of different x values, if we had, say, x equals 2, that would tell us that y would have to be equal to 5. If we plugged in x is equal to minus 100, that would tell us that y would have to be equal to minus 97. And we could keep going, but you can sort of start to get the idea that any x value we put in here is only going to give us one answer, one y value. So that means that this here is a function. Our second example, if we had y squared is equal to x. If we put a couple of different x values in there and play with it, so if we had, for example, x is equal to 9, then we need to find the y value that will give us an answer of 9 when it's squared. So you guys know that there's two answers that could give us that. We could have plus or minus 3, because either of those numbers when squared will give us 9. If we had x is equal to 100, then y could be either positive or negative 10. If x was equal to 0, then y would have to be equal to 0. So there's only one solution for that bit. But because it is possible to get two y values for any given x value, that means that this one is a relation. Probably the easiest way to tell the difference between a function and a relation is to draw a graph of the function and then do something called the vertical line test. So the vertical line test says that if it's possible to draw a vertical line anywhere on that graph that intersects the graph more than once, then that graph is a relation, not a function. Okay, so let's have a look at a few examples. Our first one here, we've got this circle. So we're going to draw vertical lines and see if we can draw one that crosses the circle more than once. So you can see that if we drew one over here, that vertical line, not that it's very vertical, but you get the idea, it doesn't cross it at all. If we drew one here, that one's still fine because it's only touching the circle once. But if we draw it pretty much anywhere else, it's going to cross the circle more than once. So this one is a relation. Our second one here is a parabola. And you can see that anywhere we draw our vertical line, and mine are a bit hard to do, you guys need to be using rulers for this. But anywhere you can draw a vertical line, you can see that it's only ever going to cross the parabola once. So because of that, this one is a function. And this last one, similar to the circle, you can see that if we drew a line over here, that's fine, it doesn't touch it at all. If we drew one straight down the axis there, it touches it once, which is still fine. But if we draw a vertical line anywhere up here, it's going to cross that graph more than once. So this one is a relation as well. Okay, so let's have a look now at the domain and range of a function. So the domain of a function is the set of all possible x coordinates, and the range is the set of all possible y coordinates. So let's have a look at what that means with a few examples. So let's have a look at these three examples. So our first one is a straight line, and you guys know that straight lines go on forever in both directions. So that means eventually it'll cover every x value and every y value. So that means that our domain, we write that as all real x. And our range, because it covers all the y values as well, will be all real y. Okay, our parabola, it will go on forever as well in both directions, so it's going to come up here. So that means it's going to cover all the positive y values, but it never drops below 0 on the y-axis. So it comes down to 0 and then it starts going back up. Our x values will go on forever in either direction though. So our domain will still be all real x like our straight line. But our range, because there's no y values less than 0, we'll write that as y is greater than or equal to 0. Okay, for our circle, it's a little bit hard to see, but our circle has a radius of 3. So that means our domain goes from 3 to -3. So that our graph doesn't have any x values outside of that range, but every value between there has a corresponding y value on it. So our domain will be that x is less than or equal to 3, but it's also greater than or equal to -3. Because it's a circle, the range, so the y values go between 3 and -3 as well. So the range will be the same. So y is less than or equal to 3, or greater than or equal to -3. Another term you might come across is the natural domain. So the natural domain of a function is all of the x values that can be validly substituted into the equation. So for example, if we had the equation y equals the square root of x minus 2, the natural domain will be anything that we can put in there and get an answer. So we know that we can't take the square root of a negative number. So that means that this stuff underneath, the x minus 2, has to be greater than or equal to 0. Then we can solve this. So we'd add 2 to both sides, and we'd end up with x is greater than or equal to 2. So that is our natural domain, is x is greater than or equal to 2. Because any x values less than 2 would give us a negative number under our square root, and that doesn't make sense. The last little thing I want to talk about is function notation. So you guys are used to seeing questions like, if y equals x plus 3, find y if x is equal to, 5. And you'd say, okay, well, y is equal to 5 plus 3, which means that y is equal to 8. So we're going to do the same sort of thing, but we're going to use this function notation. So the question instead would look something like, if f of x is equal to x plus 3, find f of 5. So then we'd write f of 5 is equal to 5 plus 3, which is equal to 8. So same concept, just different notation. Let's have a look at a few more examples. Okay, so we've got the example now. If f of x is equal to x squared plus 3x plus 1, we want to find f of minus 2. So f of minus 2, we're going to replace all of our x's with negative 2's. So we're going to have minus 2 squared plus 3 times minus 2 plus 1. So minus 2 squared is 4. 3 times minus 2 would be minus 6, and then we're going to go plus 1. So that would give us a final answer of minus 1. Our next example is if we've got f of x is equal to x squared plus x plus 2, we want to find f of minus a. So that means all of our x's are going to be replaced with negative a's. So we'd have minus a squared plus minus a plus 2. So that would give us minus a squared is just the same thing as a squared. That plus minus there will give us a minus a, and then we've got our plus 2 on the end. Right, we've got one more example. Our last example is that one step more complicated. So it says if f of x equals 3x plus 4, find f of 1 plus 2f of 0. So let's find those two things separately first. So f of 1 would give us 3 times 1 plus 4, which would be 7. And f of 0 would be 3 times 0 plus 4, which would be 4. So then we can do this, figure out that expression. So f of 1 plus 2f of 0 would give us 7 plus 2 times 4, which would give us a final answer of 15. Right, so that's some formal notation and definitions to do with functions.